Good morning. Now today we will verify the Thevenin's theorem. As I have told you already, in Thevenin's theorem, with the help of the Thevenin's theorem, we can find out the current flowing through the branch. For that purpose, we require to find out the value of ETH, Thevenin's equivalent voltage, and value of RTH, that is Thevenin's equivalent resistance. Now, for the practical purpose, we are going to use this particular circuit. Now, for this particular circuit, R1, R2 and RL we have connected. What is this RL? This is the load resistance. We have to find out the output voltage across this load resistance. Means indirectly we are finding the current flowing through this RL. So IL into RL, V is equals to I into R. So VOP1 is equals to IL into RL. So indirectly we will directly measure the output voltage. So what we are going to do, first we will find out VOP1 without using the Thevenin's theorem. Then after that we will use the Thevenin's theorem to determine the voltage across this load resistance branch. So we will find out ETH, RTH, and then we will use the Thevenin's equivalent network and we will find out the value of VOP2. This VOP2 must be same as the value of VOP1. Then only we can say that Thevenin's theorem is verified. Now let us see. For the purpose we are using this particular kit. Now for this kit we are using this 1K, this 1K, this 1K. Then same with the help of this knob we are going to adjust the E1. Now in the figure I have written E is variable. So with the help of this you can vary the voltage. Different 4 to 5 readings you can take for the Thevenin's theorem. Now let us make the connections. First we will use, as yesterday I have told you, that first you have to measure the voltage. We have to adjust the input voltage. Now let us say that we will give the input voltage as we use multimeter to measure the voltage. Now this is the voltage we have connected. With the help of this knob, we will adjust the voltage. Now let us see, let us adjust the voltage. Suppose if I adjust this particular voltage to, see, this is varying, I am varying the knob. So suppose this voltage is, for example, let us say this voltage is 15 volt. Now we are applying input as 15 volt. This input E we have applied as 15 volt. Now let us make the connections. So what we will do, we will first switch off the supply of this key. Now we will go one by one. Now let's see. This is positive of the supply. This positive of the supply means we will say this positive of the supply is connected to R1. It's connected to R1 means upper end of R1. Next end of R1 is going to 1K. Next end of R1 means we will say next end of R1 means this end of R1 is going to 1K, which is 1K. This is the value of the 1K. Next, another end of the 1K is going to negative. Another end of the 1K means this value of 1K is going to negative of the supply. Now according to this we have made the connections. Now we have to attach the load resistance. So where we can connect the load resistance, these two resistances are in parallel. So what we will do? Simple. This resistance is connected with this resistance and another value of this resistance is connected with this resistance. Means our circuit looks like this one. Circuit looks like this one. Now, what we have to do? We have to connect the output voltage across this load resistance branch. So what we will do? We will take the multimeter. With the help of this multimeter, we have to measure the voltage across the load resistance. So we will connect it across the value of load resistance. We will connect it across the value of load resistance. We have connected it. Still it is 0 because we have not switched on the supply. Now if we switch on the supply, this value is 5 volt. This value is 5 volt. We got this value as 5 volt. So this is VOP1. This first part of this experiment is completed.